Awesome. Hey guys, how is everybody? It looks like I'm looking up at you, but I recently bought a new monitor and it's over there. So I'll move you back to the front. That way it looks like I'm looking at you. Hi, everybody. Glad to see everybody. And for folks who are watching on the video, why aren't you here? But I'm glad you're here watching the video anyway. So my name's John. I do the community stuff here at Coding Nomads. I'm also a mentor for Java and Python. And I wanted to talk today about our end of year coding contest that we have. So we've been running coding contests throughout the summer. It's our first shot at them, and we've had some success and had some people participate. We've managed to give out some t-shirts and some swag. And so we want to do something special for the end of the year. And one of the things that I've done since 2017, I was actually introduced to it by a student of mine. It is a contest called the Advent of Code. And so I wanted to just talk a little bit about what is the Advent of Code and how it differs from other coding contests, how it differs from other coding things, and why you should get involved, and my approaches to how I look at these problems. And I thought I would share some of the code and the solutions that I've done in the past, but I also would like to maybe do some live coding for you guys here too, because it's not challenging enough unless I have the chance of going down in flames. So let's start off with what exactly is the Advent of Code. I'm going to move this over here. So Advent of Code, this is the 2021 version. If you just go to Advent of Code, this is what you're going to see. It'll say the first puzzle is unlocked on December 1st at midnight Eastern Standard Time. This puts folks in Europe and on the West Coast at a slight advantage to the rest of us, but that's okay. So what is it? It is a coding contest that was invented by this guy named Eric Wastel. He's been putting it on since 2015, and it is basically it's a set of problems that he puts out every year that runs from December 1st to December 25th. And if you're at all familiar with holidays around that time, that corresponds with the time of Advent, which is a big thing in the Christian religion, which is why it's called Advent of Code. It's also an awful lot like Advent calendars, if you've ever had one of those, where it's a little box and you open up drawers and you get little pieces of candy every day. So what you do is you get a problem. You actually get two puzzles every day. The first puzzle is usually an easier, light kind of intro puzzle to whatever problem is going on. And the second one is usually a lot more difficult and builds upon the first one, or makes some changes or changes assumptions that makes it a much more difficult problem. And so you don't need, as he says here, you don't need a computer science degree. All you need is some programming knowledge, which most of the folks here at Coding Nomads have or are seeking, some problem solving skills. You don't even need a fancy computer. Every problem, like he says, every problem has a solution that completes in at most 15 seconds on old hardware. And that's one of the keys here, is that if you're ever writing your code and it's taking long time to run, you might need to maybe check and see if there's a different way to solve the problem. And I'll get into that a little later here too. So, let me get back to this. I want to be able to see this part here too. Okay, so how is this different? So basically, every problem that you solve, I'm sorry, let me go back here. Every problem that you solve on the Advent of Code gives you a star. And so basically there are 50 stars that you want to get throughout the entire contest. There's 2 stars every day. So you're looking to get 50 stars. And I'm going to be 100% honest here. You can see this is my track record. I've never gotten all 50 stars. The closest I came is last year. And that's not even last year. That's last year in the past couple of weeks that I've been trying to pick these up. There are 2 problems in here that are stymieing me. I'll be 100% honest. One, I just don't know how to solve. No idea. I'm struggling really hard trying to figure out how to solve it. The second one is just a lot of code that I just got tired of writing, so I stopped. So I need to go back and redo these. 2015, I just started, and I'll do some live coding there, and I'll show you a couple of those. But 2017, 2018, 2019, this is about where I left it. So there are people who have 50 stars for all events. Okay, I'm not one of those people, and you don't have to be either. And why is that? There's some primary differences here between the Advent of Code and other coding contests. The first one is the competition aspect. There is no real, if you want to be competitive with this, if you really want to go up against everybody else in the world who's doing this, you certainly can. You know, get up at midnight EST, get the problem, try and solve it as quick as you can. You've got roughly, I don't know, about 20 minutes or so before, you know, they've got 10,000 solutions already done. So you're going to have to be quick. So what we do instead is we've got these ideas of private leaderboards set up, and I have a leaderboard. This is the leaderboard. I believe this is for my Gmail account, which is where I do most of the solving. There is a leaderboard that I have put up for Coding Nomads as well, so the Coding Nomads folks can join it. And at this point, it's just a competition between us. And even that, it's not really a competition. It's just a, hey, who's done the best, who's done the worst, who's done this, who's done that. And so you don't have to be competitive with it at all if you don't want to be. And I'm not. I use this not to be competitive. I use this to solve problems because I like doing that. I like solving these kind of problems. And in some cases, it's actually to learn a language. I might know the solution to a problem, and I'll show one of those today where I solved the problem in Java, and I'm going to try and solve it again in Python, just because I'm not sure if I can do it in Python. So, so there's that. You can join other people's leaderboards as well, so you can compete against different groups of people if you want. There's also no code-specific aspect to the Advent of Code. It doesn't run your code at all. It's not like you know, HackerRank or CodingBat or I think it was Coding Game. There's a couple others that I've gone to where you actually write your code and you submit it to them and they run it. And there is basically, Advent of Code doesn't do that. Advent of Code gives you, here's your input, here's the, you know, tell me what the output is. If it's what we expect, you win. If it's not what we expect, then we're going to tell you, you got the wrong answer and you got to go back and try it again. Nobody runs your code. Nobody judges your code. If your code's ugly, nobody cares. You got the right answer? Great. Does it take an hour to run? Nobody cares. Okay. Did it run? Did you get the right answer? Great. Is it thousands of lines long and people are coming up with 3 or 4 line solutions? Nobody cares. Okay. If you didn't even write code to solve the problem, I solved one problem in 2018, I believe, in Excel, because I had no idea how to do it in code. I knew what I was thinking in Excel, so I just did it in a spreadsheet. Nobody cares. I got the right answer. So that's the genius of the Advent of Code, is that they don't care, and it doesn't matter what code you run. There are solutions in Python, in Java, Rust, Go. People have written solutions in Lisp. People have written solutions in Smalltalk. People have written solutions in Pascal. There are some people out there who are just really hardcore who go out and they want to write it in like AppleSoft Basic on an Apple II emulator. Go for it. Nobody cares. It's for fun. It's there for you to learn and to geek out. And so that's the primary reason why I'm here and why I like doing this stuff. So that said, let's take a look at one of the problems. And I'm going to pull up one of the problems from 2015. And this is a problem that we had that I actually put up. This was the first coding challenge that we did. And I put this up as the in a slightly different format. Okay. So you're looking to get 50 stars. He tells you on day 1 what you're trying to do. And this is the puzzle for a warm-up. Okay. So you read the description. Santa's trying to deliver presents in a large apartment building. Can't find the right floor. He starts on floor 0, which is the ground floor, and follows these instructions. The instructions are, you get an open parentheses, which means that you should go up 1 floor, or you get a closed parentheses, which means you should go down 1 floor. And if you did the initial coding challenge we did, you know I changed this to be pluses and minuses. Okay. So the building's tall and the basement is deep. There isn't a top or a bottom that you can define. You can't say, you know, 100 is the top floor and, you know, negative 100 is the bottom floor. So you have to be ready for it to go into very big numbers possibly. Okay. And then he gives some examples. So for example, if you get, so now you need to figure out which floor to get to. Okay, so he gives some examples. If you have open, open, close, close, or open, close, those both take you to floor 0. So why is that? The open, you start at floor 0. The open takes you up. The second open takes you up. The close takes you down. Second close takes you down, and you're back at floor 0. 3 opens, or 1, 2, open, close, open, open, close, open, both take you to floor 3. This also takes you to floor 3. So he's giving you sample code here, or sample inputs and outputs that you can look at. Okay. He also tells you, oh, you can go to the basement level, -1. You can go to -3. Okay. So what floor do these instructions take you to? Okay. Everything that you need is here in this problem. Everything that you need to see. Okay. So the general approaches are, you want to read this carefully. Okay. Because there's a lot of information in here. Okay. He starts on the ground floor. What's the ground floor? The ground floor is 0. Okay. That's important. It's not 1. Okay. In America, the ground floor of a building is 1. In this case, the ground floor of the building is 0. So you need to make sure that you have that right. You got open parentheses and close parentheses. Okay. So that's what you're getting. And you also know that it's very tall and very deep. So you know you can't find where the top or the bottom is. Okay. So then you're given a bunch of samples. Okay. Use these samples. Use this sample code. Okay. Or these sample inputs and the sample outputs. These are wonderful test cases. If you write code to solve this, run these samples and make sure that you get the answers that they're expecting, because these are your test cases. If it doesn't work with these small examples, it probably won't work with your input. Okay, so now you get your input. So what does your input look like? Well, this is what my input looked like. And it's about, I think it was like 1,000 or 1,200 characters. And it's just a bunch of back and forth, back and forth, back and forth. So let me see if I can make that a little bigger. Yeah, it's just a bunch of open and close parentheses, just a whole string of open and close parentheses. And they're all on one line. You know, if I cut and paste this and dump it into an editor, it's all in one line. So I have to be able to read all this in to one line. Okay. Oh,
a quick question, John. Where did you get this actual input?
The actual input is whenever you go to a problem. And let me go to the second day. I'll show you. Okay. So the second day, here is a new problem, and I'm going to try and live code this one. I'm going to try and live code this solution. Okay. So it tells you day 2. They tell you, you talk about wrapping paper. You know, you have to wrap presents, and you're given dimensions, and you have to do a bunch of other stuff here. And then it says, okay, it asks you how many total square feet of wrapping paper should be ordered, and it says get your puzzle input. Every person gets different input. Okay, so my answer will not work for you. My code might work for you, but the answer that I put in here will not work for you. Okay, so what's my puzzle input look like? And I've actually looked at this. That's my puzzle input. That's 1,000 lines of numbers surrounded, so separated by X's. So every time you go to a new problem, you're given a new, you're given your input, and here's your input, and you have to figure out what the actual number is at the end. Okay, let me go back to part 1 here, because I can show you. I actually solved the first one, and my puzzle answer was 280. Okay, and that's all it asked for. It didn't care about the code, and I'll actually show off the code here. Okay, this is my code for, and these are all public GitHub repos, so you can go look at my code and you can comment on it and say, man, that sucks. But it's all day 1, day1.py. I solved this one in Python. Okay, so I have a find floor and a find basement function that I defined, and I actually this was my first solution to this. Okay, so let me go down to the main. Okay, I open up my file, I read in the lines, all the lines out of the file, and I put it into a list called directions. Okay, and this is pretty standard. I have template stuff that I use for this, so this is pretty standard when I open up the input file. So it's just read in every line for every line that's in the file, and strip, which is just take the white space off the ends. And then I said find floor, and because it's a list, I had to do direction sub 0. So I said, okay, so direction sub 0 is the line. That's the entire line that I have. And so I came in here and I went to find floor. So my first solution was fairly simple. Floor starts at 0. And then for every character that's in, let me make this a little bigger. For every character that's in the string, if it's an open parentheses, increment the floor. If it's a closed parentheses, decrement the floor. It's a fairly straightforward solution. It's not very Pythonic, and I wasn't happy with it. That's why I have a comprehension solution and a dictionary solution up here. They both give you the same number. So if I run this code, if I run that code on that big, huge 1,000 character long string, it spits out the number down here, which is 280. And then we go, okay, I get the, I got the answer. It's the right answer. So then it says, oh, okay, part 2. Now we have to do part 2. So what does part 2 say? Part 2 says, find the position of the first character that causes you to go into the basement. Okay, so now I don't need to find out what floor I'm on. I need to figure out, when do I go into the basement? At what point in this entire long string do I go into the basement? Okay, and I don't go into the basement until character, actually it was longer than 1,000. It was character 1,797 is the first one that takes me into the basement. So I had to figure out, when do I go into the basement? So now my code for finding the basement is this. And I've commented out a couple things where I start with the floor, and then what position, what character am I looking at? And I just do a while loop. While the floor isn't -1, which means I'm not in the basement yet, I just keep doing the floor adding and floor subtracting like I did before. And the minute that that character gets me into that basement, the while loop will break, and I just return my character position. Actually, character position +1. So my second solution was a different one using enumerate. And I have there's also a dictionary solution in here where I use this dictionary lookup to find whether I should go up or down. So there are a couple of different ways to solve this. Any of these solutions don't take that long to run, but it just shows you that, I came up with an initial solution that worked great. And then I went back and I refined it later. So you don't have to come up with the clever solution. My first solution for finding the floor was, this is code that you could write in any language. It's not Pythonic, but that's fine. It got me the solution. Nobody's commenting on the Pythonic nature of my code except me. And so I went back and I just refined it. So my approaches to these things. So what are my approaches? So this is the basic approach to it. My basic approach to this are, definitely read the problem. Read the problem carefully. Read everything carefully. It's all here. Okay. There are no trick questions. Okay. Nobody's trying to trip you up. There's nothing in here that is trying to get clever with you or to make you think, oh, did he mean this or that? Or he's trying to be as clear as possible. Okay. So it's not a trick question. There's all this data in here, and he's trying to be as specific and as particular as possible. There's a lot of particular language, but it's not going to be a trick question. Okay. Use the sample data that you're given. Okay. So he's got sample data in here. Use the sample data and the sample solutions. Okay, because they will help you. There are test cases that'll help you test your code. Run it through the debugger. The debugger is your friend. These sample data and test cases are your friend. Run it through the debugger and try it out. If you get stuck, there are places to go. The best place to go is right here. It's the subreddit Advent of Code up on Reddit. They have got all sorts of stuff here. Okay. Need help. People are still doing our Advent of Code day 15. Okay, so somebody says they need help in part 2 of Advent of Code day 15. So if you're working on day 3 for Advent of Code 2015, you might want to look at this and see, okay, what does he help? Can you help? Or maybe you're having the same kind of problem. They also post mega threads, and I'm going to open this up really quick. Every day that there is a solution, every day that comes up where there is a solution done, they wait about 20 or 30 minutes after the problem drops. As soon as they have enough solutions that the master leaderboard gets full, then they open up a mega thread And now people can go in and post their solutions. So here's the solutions for day one, Advent of Code 2015. I just clicked on that. So basically, here, how I solved part one: copy the text into a notepad, replace every open paren with a +1, replace every close paren with a -1, open up JavaScript console and drop it in there. No code required, and nobody cares. Nobody cared. It's wonderful. It's wonderfully cheap. You don't even need to code. All you need to do is drop it in a notepad. I think that's awesome. So you can go and look through these and see how people solved it. If you want to, you want to look and see, maybe you're trying to learn Rust or Go, look up and see if somebody has a Rust solution or a Go solution, and you can look up how they wrote their code. Okay. The one thing to be careful of is that you will find, if you're looking for hints, if you just need a hint as to which way to go, what am I looking for? How am I trying to do? You will find spoilers here. People are usually pretty good about avoiding that or hiding them or saying, hey, spoiler alert, but you may still find them. Okay. Anybody have any questions so far? Anything?
I mean, I think it's really cool. I've seen another person solve that one using Vim. It's really neat. It is, very different from most coding challenges, right? And the fact that it's not about your code structure or coding skills. It's about finding the answer any way you would like.
Yeah.
But there was a couple questions in chat from Scott.
Sure.
About is it a good best practice to save your input as a file, like you did in that first example there, and processed it?
If it's a big input, and so I can go back here, so there's my input, so it's all one line. If it's a large input like that, then yes, because the other thing that I do with other, let me see if I've got one here for day 3. Yeah, so for day 3, I've got my input file, which is a bunch of ups, downs, lefts, and rights. Okay, it's huge. Okay, but I also went through and said, okay, for day 3, let me go back to day 3 and show you what that one looks like really quick. Okay, so day 3. So basically, he's trying to find. Now you're trying to find houses. Where are the houses from wherever you start? So you've got arrows that point up north, south, east, and west, and you have to figure out where he's going and how many houses he visits along the way. And so, so how do you do that? Well, here's some sample stuff. Here's sample code 1. Here's sample data 2. Here's sample data 3. Okay, so these are my 3 samples. So if I go up here, I've got sample 1. It's just that code, or that input. Sample 2, same input. Okay, and then sample 3 is his sample 3 input. So I just cut and pasted it in there, and then I run my code against it and make sure that I get the right answers coming out. And so yes, I think it's best to put the sample data into a file like that. That way you can read it in, and you can put you put your input in there, you can put your samples in there, you can run the code against it without having to change anything other than, in this case, the only thing I have to change is this. I change input to sample, or sample 1, sample 2, sample 3, make sure I get the right answers. Everything's good. So.
Yeah, great. Yeah, super clean doing it that way. And I assume also that your personal input remains the same no matter if you re-access the puzzle a second time or a third time?
Yep.
Okay.
It does not change. If it did, that'd be really weird. So
yeah, it would add another level to the challenge, that's for sure.
Yep. There are times that I've solved a problem. I think I have a solution. I put in the answer and it'll say that's the answer, but for somebody else's input. So he's got a finite set of input files and a finite set of results that he expects. And if your algorithm is wrong, you might wind up getting an answer that is correct for somebody else's data. So, and he can actually detect that and say, yeah, that's the right answer, but not for your data. Make sure that you're using A, your data, and B, if not, then something else is wrong there. So the only time that I don't use a separate input file is when like the only thing he gives you is a number. You know, like he may say, you know, if you follow these rules for, you know, so many iterations, you know, this is the answer you should get, you know, and here's how many iterations you should do. And he just gives you a number. So I'll just put that in as a variable sometimes instead of in an input file. It depends on the input though. Any other questions?
You get as many tries as you need, right? You'll get
Yes.
locked out of a problem after 3 tries or something like that.
No, it may be like if you try it once or twice and you get the, you know, if you get the wrong answer, like, you know, fairly quickly, it'll say, you know, that's the wrong answer. The first time you do it, it'll give you the wrong answer. And then if you try it again really quick, it'll say, no, that's the wrong answer. And now you got to wait a minute. And then the next time you do it, it might say, no, now you got to wait 5 minutes. Because what they don't want you doing is saying, oh, okay, it's a, you know, it's an off by 1 error. And so, you know, you say, okay, well, let me go up a number and then go down a number. And at that point, you're just guessing. And it detects whether you're guessing, whether you're trying to do that kind of stuff. And it tries to prevent you from just inundating them with, you know, basically just throwing in, you know, random numbers at them. So I think that's what it's there for. So you're never blocked out, but you will be time limited in the number of answers that you can give. And you know, in case you're thinking, I'll just you know, blast them with, you know, I'll just write some code to blast every number from 1 to 1 trillion in there, and let's figure out which one works.
Throttling.
Yeah.
One quick question, John, is maybe you've already shared this on Slack or the forum, but how do people join the Coding Nomads leaderboard for this year's contest?
Yeah. So it is up on Slack. When you go to the Coding Nomads site and you set yourself up, you'll log in using
Coding Nomads site or the Advent of Code?
Advent of Code site.
Okay.
So you go to the Advent of Code site. I'm going to log out here really quick, and then I'm going to go here to log in. Okay. And so it says, you know, to play, please identify yourself with either GitHub, Google, Twitter, or Reddit. And I have 2 accounts here. I have my GitHub account, which is my personal one, and Google, which is using the Coding Nomads account that I have. And so when I log in as GitHub, it does OAuth, and now I'm in as me. What you can do is you can then go to Leaderboard, and it'll say, here's the full Advent of Code leaderboard. So here's the people who scored highest. And then you can go to private leaderboard. And if you're given a code, you can join a private leaderboard by entering its code here. Mm-hmm. And we put that code up in Slack. It's in the forum as well. I forget exactly what the number is. I think this is my own private leaderboard, but let me do this. Let me log out.
Yeah, and we can, in the Slack and forum with this recording, we can share that code as well to encourage other people to join the.
Right, exactly. So when you join, there's 8 or 9 of us who are currently there on the leaderboard. I believe Jared is currently first with 0 stars, followed by everybody else with 0 stars. I don't know how he wound up first. It's my leaderboard, but I'm not even first. So yeah, so the sorting algorithm's got to be going by, I don't know, good looks or something. So, so you can go and you can solve these problems. You'll solve them as they appear every day. Now you can go back to older ones and then pick any problem you want. Like if I wanted to solve day 25, I could, and I'll go through day 25. I'm not going to do that right now, but so those are my basic approaches to solving these things. After I've read the problem, I know the debugger is there. The first thing that I really think about is how am I going to store this data? Because some of the data I need to, in the 2 examples we've seen, the data is fairly straightforward. It's basically a string of characters. So I could just treat it as a string of characters and process every string. Some of the data though isn't conducive to that. Some of the data is in a much different format, and how you store the data becomes a big part of whether or not you're going to get a good solution or not, whether you're going to get a viable solution or not. And let me see if I got to pull up one of these things here. So day 17, so let's go 2017, and we're going to go to day 5. Now, 2017 was my first year doing this. I will freely admit, if you're a Python guy, I'm sorry. But I was teaching Java at the time, and I exposed my students to this. And actually, this is a problem that I gave them for their winter break. So I said, solve this one over your winter break for 20 extra points. I had 2 people do it. So, so basically 2017 day 5, the input for that is, where's my inputs? 2017 day 5. This is before I had all of my other stuff kind of working. So I had to do part 1 and do part 2, and I've got my main here. And so there is an input problem 5.txt in there somewhere. Let me see, where's my input? Really? I did not commit my, oh, I know where I did. Duh. It's not under source. There, input, problem 5. So this was the input for problem 5. It's just a bunch of numbers, positive, negatives, etc. Okay. And what these represent, when you read through this, they represent jumps. Okay. So the way the problem is stated is you are basically jumping through memory. And so every time you hit this number, it tells you how far ahead to jump. And then every time you jump, you have to increment the location. So I have to jump ahead 2 and increment that 2 to a 3. And then I jump ahead 2 and increment that 2 to a 3. And then I jump -2, which means jump backwards. And so now I increment that to -1. And so now this is a 3. So I have to jump ahead 3, 1, 2, 3, and increment that to a 4, et cetera, et cetera. So that's how he's staging the problem. So how do I solve this problem? How do I actually make this problem work for me? And basically what he wants to do is he wants to know, how many iterations do you need to go through this before you jump out of memory, before the jump takes you outside of the memory block? And so I have 1,090 lines here of all of these different things. So, you know, figuring out how to store this data was the key to it. And this is why I gave it to my students at the time. And it's because the obvious way to do this is in an array, which is exactly what I did. I created an array with 1,090 entries. I read in every number and stuck it into that array. And then I called do part 1 and do part 2. And do part 1 just sits there and says, okay, you know, where am I jumping to? Increment that particular thing and then go to the next thing. So storing it in an array makes sense. I could have stored it in an array list just as easily. But trying to figure out what data structure to store it in. If I kept it all as a big long string, it would have been impossible to solve. Well, impossible is not the right word. It would have been much more difficult to solve, to try and figure out where to jump to. So trying to figure out what the data structure is usually the biggest part of the whole thing. I have learned about I actually learned about the deck data structure. Folks know what a deck is. DEQUE stands for a double-ended queue. It's a dynamic data structure where you can add things and subtract things from both ends of the structure, so you can go from one to the other. There was a problem that we had. There was a problem that you had where it was a circular kind of. The problem was posed as you've got this circle of numbers and you keep having to insert things into different points at the circle, and you're trying to figure out, okay, after you do all these rules and you insert about, oh, I don't know, 1 million things into the circle, then you find one of them in the circle. And I initially tried doing that using an array, and it took hours trying to, or actually an array list, just trying to dynamically size the thing and doing everything. It was a ridiculous amount of time. And then I learned about the deck, and I realized it was a lot quicker. I took a solution that was taking hours and hours to run and knocked it down to about 3 or 4 seconds just by using the right data structure. So that's 90% of the problem for me, is trying to get the right data structure, because once you get the data structure right, then it works.
I concur on that entirely, John. A lot of times with these coding challenges, for instance, in a coding interview where you're getting a kind of a technical challenge, the first step, oftentimes when you have the right data structure, the problem is relatively straightforward, and it's determining the right data structure that oftentimes the interviewer is even looking for, right? Like, okay, this person understands that this is a that this requires a tree, or that this requires a try, or that this requires a hash map, right? That shows that the person is understanding kind of the premise of the problem. And it's very, anytime that you're looking at a challenge like this, just like you say, thinking about, okay, what's this data look like? And what am I needing to do on this? Do I need to insert things really fast? Do I need to find things really fast? Do I need to, what's the primary action? And then based on that primary action, what is the most appropriate data structure to use?
Right. So thank you for that, Ryan. I appreciate that. And you will learn, you may not know the structure. I didn't know what a deck was. I had never used one before. And I learned, that number one, there's a deck primitive in Python and in Java that you can just use. And I just had to look up and learn how to use them. So you will learn how to use these things. So if you're not familiar with the data structures, don't let that be a hindrance. Use it as your, this is the reason to learn about these things. So,
yeah. It's interesting you brought up deck because I was actually introduced to it in a very similar way. I was racking my brain for hours and hours over this particular challenge. And yeah, once I finally discovered deck and how it uses basically a configurable predicate for sorting and just the entire way it worked, the solution just kind of fell into my lap at that point. So it's kind of cool that you brought it up, and I can totally see concur with that experience. So
yeah. Cool.
Cool.
Yeah, and you will learn a lot of different things too, things that you didn't know. Like there's this idea of what they call Manhattan distance. So if you think like you're in a city, if you think of like the distance between 2 points on your screen, you could either go diagonally, so straight across diagonally, or you could do what's called the Manhattan distance, which means you can only move vertically and horizontally. And they call it Manhattan distance because it simulates how you get from one point to another, from one corner of a street to another corner of a street in Manhattan. You don't go diagonally through the blocks. You have to go north, south, and east, west. And so the idea of Manhattan distance between 2 points is interesting. And there's a lot of problems, not a lot of problems. There's more than one problem in Coding Nomads where he's talking about calculating the Manhattan distance between 2 points on a grid somewhere. I've learned and refreshed my memory on a bunch of different kind of standard algorithms like breadth first, depth first searches, shortest path algorithms, tree traversals, some sorting algorithms, that kind of things. We talked about the different data structures. One of the things that is good in one of the other characteristics of the advent of code that I think is great and lends itself really well to the types of problems that it gives is that there is a unifying narrative throughout the whole thing. It's always around Christmas time. It's always around the secular nature of Christmas. It's always Santa Claus and his elves trying to get presents to people, or having some problems getting presents to people, and 25 days worth of stories about this. And because of this unifying nature of the story that he tells, he can have recurring elements that pop up all the time. 2019 was a great year for this. He introduced in day 2 the idea of this, what he called an int code computer. And so you had to write a computer simulator, basically your own little virtual machine. So you had to provide, you had to provide variables for the registers, you had to provide space for memory, you had to provide input and output. And over the course of 5 or 6 different days, so it was like day 2, day 5, day 9, day 15, and further on, you added more and more features to this int code computer. And then in different problems, you would use the int code computer. So your program input would just be, here is an int code program to run on your int code computer. Tell me what answer you get. And so it was a test not only of, is your int code computer working properly? Is that first thing that you wrote on day 2, does it still work on day 15? But also, now you're going to have, you're adding new features, you're adding new input, you're adding new things. Day 24, I think it's day 24 in 2019, uses the int code computer. It actually uses 50 of them with input and output queues that are connected to one another, that are feeding data back and forth. So now you've got to write this entire 50 computer network simulation. And I love that. That is just so cool to me. And I'm sitting here trying to figure out day 2 because I need to change my computer, but I love that kind of stuff. And so you'll find problems that you absolutely love. You'll also find problems that you absolutely hate. There was one of them that used the encode computer. Basically, you got an encode computer program that would do the game of Breakout. And so part 2 was play the game and you know, what's your score when you break everything out, when you get everything done with. And I hated that one because now I got to deal with visualizations. I got to deal with basically text on the screen visualization, or I've got to do some other weird visualization thing to visualize this thing coming out of this little computer. Those I don't like that much. And that's one that still stymies me to this day. I just haven't gone back and done it yet. The encode computer, the simulation, wonderful. As much as I like writing games, I didn't like actually having to do that game. I go figure. So some of the other problems that are there, you'll get some obfuscated problems, some real things in computer science that are just kind of obfuscated or twisted a little bit. There's a hash algorithm that he gave on day 10 in 2017. So it's called a not hash that you use later. 2020 day 19 is basically you have to implement regular expressions, which was really weird, and that's the one I have to rewrite. Day 18 was basically Nicholas Veer's shunting yard. So how do you convert infix expressions, like 2 + 3, and how do you 2 + 3 × 9? How do you make that actually compute? How do you figure that out? There's an algorithm called a shunting yard that does that, and it's basically an odd rule. You throw in some weird rules and you implement a shunting yard. Day 5 is some really weird binary encoding that you got to figure out. Once you figure that out, it's easy. The last day of 2020 that I'm working on now is basically a variation on public-private key encryption, which is kind of fun. So, and so there are all these different types of problems that you see, and you'll see these repeated throughout. So if you've solved one of them one year, you'll solve them again the next year. So. Okay, that done. I've gone through one of my solutions, and I wanted to actually work through one, if that's okay. If folks are okay with working through a problem, yeah,
absolutely.
This might go badly. We'll see. So what I'm going to do is this. I'm going to go here. I'm going to change my sharing here real quick. Okay. So bear with me for just one moment. I'm going to drop that. And I'm going to share. I want to share this entire desktop. Share. There we go. Okay. I'm going to push. Yeah, that's fine. Okay. So everybody should be able to see my screen at this point, correct? And I've got, some code back here that I'm going to work through. And I've got the description of the problem up here. And so, I've read through this, and I'll go through it again and hopefully just summarize it. So, so Santa Claus's elves are trying to wrap all these presents, and they need to figure out how much they need to order. They have a list of all the presents that they want to wrap, and so they want to make sure that their order is as small as possible. They don't want to order more than they need to because wrapping paper costs money. So every present they have is a box, okay? So everything is a definite right rectangular prison, so it's all a rectangular box. And so you can calculate how much wrapping paper you need by basically calculating the area of each face of the box and adding it all up. So length times width times 2 will give you one face, width times height times 2 gives you 2 faces, height times length gives you the other 2 faces. And you need a little extra paper for each one because there's overlap. You got to be able to cover up that logo on there. So, and so the amount of overlap they need is basically the area of the smallest side. Okay, so that's the entire problem. That's basically what they're trying to solve right now. Okay, so he gives you some examples. You have a present with the dimensions 2 by 3 by 4. Okay, so 2 feet by 3 feet by 4 feet. And so you have to figure out, okay, so it's 2 times 3 is 6. So you multiply that by 2. 3 times 4 is 12. You multiply that by 2. And then 2 times 4 is 8. You multiply that by 2. And that's the area of the cube. So that's how much you need. And then you need to add on
John?
an extra 6 square feet. Yes.
Sorry to interrupt. Do you mind making this text just a little bit bigger for those of us that's just on the laptops?
There you go.
Yeah, thank you.
Make it like that. So, okay. So if a 2x3x4 square box, you have to figure out what the area is, or what the surface area is. And then what's the smallest dimension? You need to basically add that much more. So you've got 52 square feet that you need for this particular box, plus an extra 6 square feet, because 6 is the smallest area. It's the smallest, the area of the smallest side. If you have a 1x1x10, well, that's 2 times 1 plus 2 times 10 plus 2 times 10 is 42 square feet. And then an extra square foot, because that's the area of the smallest side. Okay. And so now you want to know, everything's in feet. How many total square feet of wrapping paper should you order? Okay. So what this is basically saying is, for everything that's in there, I need to calculate this. I need to calculate what the surface area is, plus figure out the extra little slack that needs to be in there. Okay. So do folks understand the problem as it stands so far? Okay. And then my puzzle input is this, and saw this earlier. Make it a little bigger. Okay. So basically the puzzle input is a number, an X, a number, an X, and a number. Okay. And I've looked at them all. They're all integers. So, and that's a good thing. You know, I don't have to deal with decimal numbers. They're all integers. So, okay, so how am I gonna, what am I thinking of right now? What I'm thinking of is, how am I gonna split that string up into 3 integers that I need, okay? And I'm doing this in Python. So let me go back here, okay? So I have, this is my input file. That's all of them. Is that visible for you, Ryan? Do you need me to make that a little bigger still? Okay. So I've actually gone through this. There are 1,000 of them here. So if I go all the way down to the bottom, there, 1,000 lines. So I have 1,000 different numbers that I'm going to be processing here. Okay. And I also have my samples up here. So I have sample 1 and sample 2. And those are the 2 samples that he gave me. So first thing I'm going to do is I'm going to say, let's make that sample 1. So I'm going to read in sample 1, and I'll read in 1 line at a time. And I'm going to pass this line, pass all of my lines into part 1. Okay. So the first thing I need to do is I need to figure out what those 3 numbers are. Now, Python has got a wonderful string method that I know of called split. So what I can do is I can do a 4-line in lines. Okay. So I'm going to do a loop through every line that I'm given. And I want to split that up into 3 different numbers. Okay. So I'm going to say, how did he put it? Let me go back here. Whoops. I'm going to just make that a little smaller. He had it as length, width, and height. Okay, so I'm going to try and keep with that. So we're going to say length, width, go here. So length, width, and height. Okay, and that is going to be equal to, actually, it's not going to be equal to that. I'm going to say dimensions equals line dot split. And I'm going to split it on the X's. So now dimensions is going to be an array of basically everything here. It'll be 23 and 11, but it's still going to be strings. So it's not integers yet. It's still strings, because split returns strings for me. If I go to split, it returns a list of strings. So I'm still going to need to convert those to integers.
So just to clarify, dimensions, the result will be dimensions is an array with 3 elements. At the index of 0 is 20, at the index of 1 is 3, or I guess in sample 1, at the index of 0 is 2, 1 is 3, 2 is 4. Right. They're all strings. So by splitting it on the X, that's basically the delimiter, and what's remaining, each remaining element gets put into a new index in the array. Yeah. Right.
Exactly. And we can check this out really quick. I'm going to debug this. Okay. And so we'll go through this, and we'll come up here, and I'm going to say, so lines, so dimensions is equal to line split on the X. And so if I just step through that and I look at my dimensions, dimensions is now a list of 3 different characters, 3 different strings, 2, 3, and 4, which is exactly what I wanted. Okay. So remember I said the debugger is your friend. This is how it's your friend. I can check, I can just run this at any time and just check it all the time. Okay. So I'm gonna stop. Okay, so I know I'm getting the right things out of this. So now I'm gonna need to do some conversions, but that's okay. Okay. For the sake of being as clear as I can, I'm gonna say length is equal to int dimensions sub 0. And then width is equal to int of dimensions sub 1. And then height is equal to int of dimensions sub 2. Okay, so now I've got them as integers. Length, width, and height will be integers for me. Okay? And this is just for clarity. Again, nobody's judging my code. Nobody, you guys are because you're looking at it, but nobody else is going to judge this code. Okay, so what I need to figure out now is I need to get the areas, the surface area of the different faces. Okay, so why don't I make LW be equal to L times W? Okay, length and height is equal to L times H, and width and height is equal to width times H. Okay, so those are my 3 surface areas. Okay, which is what I need to figure out, because I'm going to have a cube, and so the top and the bottom will be the same, the 2 sides will be the same, front and back will be the same. So I've got these 3. So now what I need to do is I want to figure out what the slack is. What's my extra? And remember, we go back to here, he says that the little bit extra is the area of the smallest side. Okay, so I also know Python's got this wonderful thing called min, okay, which will give me the minimum of any numbers I give it. And so I'm going to give it length width, length height, and width height. And so that'll tell me what the smallest one is. Okay, I could do this with an if statement as well, but I use the tools that I have. If I were doing this in Java, it'd be math min. If you're doing it in another language, I'm sure they have a min function of some sort. Okay, so now all I need to do is calculate what the total area is, and they told us what the total area is, or the total amount that we need to get, and that's 2 times the length width plus 2 times the length height plus 2 times the width height plus my smallest. Whoops, not W, 2. Okay, so that's my area for this one. And now I need to basically add this all up into a total area of some sort. So, okay, total area is 0. And so we can say total area plus equals area. Okay, so we'll just add that to the total area. And then at the end of part 1, I'm just going to return total area. Okay, so this is going to read every line, split it up, get my dimensions in integer format, calculate the sides, the surface area of all the sides, figure out what the smallest one is, and then figure out what that area is and add it on to total area. Okay, and so I can run this now because I'm going to print this out. Let's run it against my sample data. I'll just run it. And so my sample data, it came out and it said 58. So this was sample 1. 2 times 3 times 4 came out with the answer 58. Is that what he said here? 2 times 3 times 4 requires this 52, 58. Perfect. Let's run it against sample 2. Run all my test cases. If I was a smarter man, I would have set this up in PyTest and had test cases for all this, but I'm not that smart. So let's run it again under sample 2. Now we get 43. So take a look. Does this come out to 43? It does come out to 43. My 2 test cases are working just fine. So let's go for the big one. Let's take all 1,000 of them and let's see if we can do this. And we'll run it. Boom. And we come up with an answer of 1,606,483. So I'm going to copy that out of my terminal. I'm going to go over here. I'm going to put that answer in here, 1,606,483. Is this the right answer? We hit submit. That's the right answer. 1 gold star closer to powering. So code done. So now it says, let's go to part 2. Part 2 is usually a variation on part 1. Usually does something to make it a little trickier. Now, I've never seen this one. The other one, part 1, I read. So I knew I had this in my head as to how I was going to solve this yesterday. Part 2, I got 3 minutes. Okay, so they're also running low on ribbon. Ribbon's all the same width, so they only have to worry about the length, which they'd like to be exact. The ribbon required to wrap the present is the shortest distance around the sides or the smallest perimeter of any one face. Okay, so each present also requires a bow made out of ribbon as well. The feet of the ribbon required for the perfect bow is equal to the cubic feet of volume of the present. Don't ask how they tie the bow. Okay, so what do you need here? You need 34 feet. So it is the ribbon required is the shortest distance around the sides or the smallest perimeter of any one face. So I either need to figure out, so the perimeter, yeah, so the smallest perimeter is what I need to figure out here now. Okay, so I need a perimeter thing, and then I need a volume thing. Okay, so how many total feet of ribbon do they need to order? Okay, so let's go through this again. So we're going to pass lines in again, and we're going to do the, we'll have a total length. I'm going to set that equal to 0 for line and lines. And I'm going to be cheap, and I'm going to do this. Sorry about that. Let's back that up. Okay.
You're doing a great job in a hurry, so you're not judged at all. But for people watching, anytime I copy and paste even more than one line of code like that, I make it a function or a method that I can then just call in both places. But you're doing a great job, John.
Yep, and that would be a refinement that I do after the fact. I would definitely pull that out and do that somewhere else. So
I thought we weren't judging the code.
Yeah. Okay. So I'm going to do the same thing here. I'm going to do, this time I'm going to do perimeters. I'll do LW equals, what is it? It's 2 times L plus 2 times W for a perimeter. And then we do LH equals 2 times L plus 2 times H. And then we do WH equals 2 times W plus 2 times H. Okay. So those are my perimeters. And then we're going to have a volume, which is equal to width times height times length. Okay, and then I actually need, what is it? I need the smallest, and that's going to be equal to the minimum of LW, LH, and WH. So that'll give me the smallest. And then that's the volume. And then we'll say total length plus equals smallest plus volume, which is how basically what I should have done up here. Okay, I think that's right.
So it's getting me the smallest and then the next smallest. So maybe determining the largest would be better.
Well, determining the largest, it says here I need 2 times 3 times 4 requires 2 plus 2 plus 3 times 3. It's the smallest dimensions. 10 feet of ribbon plus the volume here. It says the shortest distance around the sides or the smallest perimeter of any one face. Right. Yeah, so I only need one of the, I only need whichever one here is the smallest.
Yeah, sorry, because you're doing the calculation I got you. Yeah.
Okay. And then the volume is what gets added on. Okay. And so here we will return total length again. Okay. Okay. So let's see what we get. Okay, so now I've got 3,842,256. Okay, so before I do this though, let's be smart here. Let's run this on sample 1 and make sure I get the right answer. Okay, so sample 1 tells me it should be 34. Sample 1 says, hey, 34, so that works. Sample 2 says it should be 14. So let's do that. Sample 2 is 14. Yep, that works. Okay, so let's do my input again and we'll run it again. Boom, 342, and we copy that out and we go down here and we paste it in. And is that the right thing? That's the right answer. 1 gold star closer. Yay. Okay, so really quick calculations doing this stuff. And then we can go back here and you can see now day 1, day 2, day 3, each have 2 stars. And basically this is your reward. If you want to gamify it, this is your reward, is that the graphic becomes more colorful and more animated. The one from 2017 is kind of fun. So you can see it actually starts drawing itself all over the place. So loads of fun. And I still have got a couple more to do here. So, okay. So that's basically it. That's the advent of code. And that's the kind of coding that you do. Now, when now that I've done this, I'm going to go through and clean this up a little bit. There's got to be a better way to get those numbers out of here than doing this in split. There's got to be, I'm sitting here thinking there's got to be a comprehension way to get that out of there. So, and I think I've got an idea, but, and then I would kind of do this up. And actually, since I need to do the same thing all the time, I actually might do it down here in main and just process it all here in main and then just pass in arrays of numbers, which would be just as easy. So, but now, so now it's clean up the code. Now it's okay, I've learned something, now I can clean up the code and get it to work. So that's it. Any questions? Any other questions?
No, it's been great, John. Yeah, very cool demonstration, very cool introduction to the advent of code. Looking forward to it.
This is lots of fun. Basically, this is, if you like problem solving, if you like doing this stuff, and it really is just for fun, but a lot of the problems that they give you, solving these problems really sets you up for solving real world problems. Some of these things here, really do, they do have applications out in the real world, and you learn how to use a lot of the different tools that you have. You'll get a lot better at doing these tools, at thinking your way through the code, and to make things a little more, making them efficient, doing them quicker. It definitely has some real world applications. Like I said, I do it for fun, but it definitely has some benefits beyond that.
Yeah, some of them really look like my past technical interviews.
Yeah.
I mean, I had that question in one of the interviews. There was a dragon and it was jumping on the stones, and you had to count just like you showed in that example, and it was an actual technical interview for a cybersecurity company, but I forgot the name. Yeah.
Yep.
Yeah.
So yeah, they do, they do an awful lot of stuff. Like I said, some of the stuff here, like the not hash from 2018, 2019, I think somebody said it actually looks an awful lot like an MD5 hash. So, some of the stuff actually has some real world applications. He kind of obfuscates it, but this is real world stuff. And so knowing how to do it and do it efficiently, like I said, Jared said too, you learned about, I learned about the deck, which helped out a lot. And I actually used it again in 2020. And I wouldn't have known to do it if I hadn't screwed it up the first time. So, yeah.
This is really cool, John. And a few people during this call have joined the private leaderboard on Advent of Code, Shadas and myself, and maybe a couple others. We've got 10 people in there now. And awesome. So, and we will share the private leaderboard code on Slack and the forum again, and encourage as many people as possible to join. I think it could be really fun, and not necessarily, as you mentioned earlier, as a competition, but just as another good, fun motivation to be learning new things and pushing ourselves and solving new challenges. And another thing that we could do as well is kind of get some of the people that are in the Advent of Code challenge together. Like we could get some forum posts that people can post to, or some Slack channels that people can post to, maybe even get people together for like a once a week meeting to go over what they've done and share their solutions, and make it more of a collaborative approach for anybody who's interested. Just because this is, at the end of the day, the real prize is what we learn, right? So, so we're all in this together to help each other. I think this is really cool. I really appreciate you going over all this, John. Fantastic presentation, and yeah, thank you.
Cool. Thanks, guys. I hope I see you guys out there. I was planning on starting a forum post on all this stuff, kind of like the daily post of what we're doing, what the daily problem was, and posting solutions a day or two later for folks who are trying to catch up, or who need hints and stuff like that. So yeah, I'm really looking forward to this. I've done this, like I said, since I was teaching 2017, and every group that I've been in, I've tried to make sure that people get involved with this stuff. And I'm hoping that we get a lot more people involved, because these, I just think these are loads of fun. So
Yeah, I can count me in. I'll do everything I can to get as many folks into our little private leaderboard as possible.
right.
Yes,
Okay. Awesome.
Great. Well, thanks for joining, everybody. Thanks. Great to see you, Shadas and Efim and Scott and John and Jared and John and everybody. Great seeing y'all, and thank you again for your time.
Yeah,
Right.
thank you so
Thanks,
much.
guys.
Thank you so much. Bye.
Yep. See you later.
See ya.